For many beginner programmers, pointers are considered a nightmare. You've probably known the data types int, string, array, and even created your custom data types, but when you see the *int, or worse, the *int, you black out. Well, today I will walk you through understanding pointers and why they are useful. To cut the chase, pointers are useful and powerful because they make your program much faster, and we will see how is that done together. We are really going step by step, but if you follow along, you will be able to understand everything about pointers once and for all. And if you are only interested in structs, I have included chapters, so feel free to skip there. Okay, let's start with the most simple thing that anyone can probably do. Let's create a variable x with type integer and assign any value to that x and then print it. The basics of programming, right? So let's run this, and as expected, our x is of value 5. So in real life, every variable's value is stored in the memory. And so to be able to reference those values, we need their address. Because in the memory, we have so many things stored, each one is assigned a specific address. And that address is called a pointer. I am giving a disclaimer here about my handwriting, it is not my best feature. So let's use this example in here. If I decide to show you the address of x, I would use the ampersand next to the x. And that gives me the address. So this is where the value of x is stored, and this is what we call a pointer. Now let's go to where the confusion starts, which is creating something like this, using the star. And what is it actually saying is, I want to create a pointer, I want to reserve an address, and that's it. You're not giving a value, you just went to your computer's memory, took a slot and said, okay, in this slot, all future values will be integers. And this is actually what creates a difference between an integer pointer, a string pointer, or a boolean pointer, whatever you want, but it means later on every value added to that memory slot has to be of that type. And so in here we have integers. So this is how an address looks like usually. This is written in hexadecimal. You don't need to care too much about how it looks in the scope of this video. Now let's print that y. And now you don't need to put that star. Every time you want to reference the pointer, the address itself, it is in y itself. So let's clear this and run the program. So as you can see, the address is nil. It doesn't look like this. Because when you create a pointer without assigning to it any value, usually it is going to give you nil. At least in Go it does. But it is not safe to keep pointers this way because it's kinda unpredictable. So since we said this is a pointer, it means that we can assign to y the address of x because they are of the same type. As you can see in here, if I'm going to remove the ampersand, I'm having an error because the variable is int and the pointer is not an integer, it is a *int. And as you can expect here, we will see the same addresses, of course, and it is. So I know some of you may be questioning why we don't have the same addresses in here and here. Well, to answer that in a very quick and easy way, these are virtual addresses, like in a virtual memory. So we can get any random address at each compilation. Like in a very high level way, that's the answer. If you want to learn more about how addresses really work in the computer and the difference between the virtual address and the real addresses, well, it's such a wide sea, but it's really worth the dive, I would say. I just wanted to answer this question in case you had it. Okay, good. So now you want to create a fresh new pointer, let's say, and actually reserve an address. And the way to do this without getting nil and without having to assign like some other taken address is by doing this. And here we're going to use something that maybe you have used with structs, and we will get to structs in a minute, but it is by using new and then the type of data. So we can see here that we have new type, and it's going to give us a pointer to that type. And let's put it in here. Now let's print that. As you can see, y is still nil, but z was assigned a proper address. By using new, we also initialize the pointer. And so this means if we want to insert a value in here, we will again use that star. Every time we want to reference the value, like saying in this address, I want this value, then you use the star again. So first you declare the pointer using the star, but then every time you reference the address, you don't use it anymore. But when you want the value, you use it again. It's like saying in that address, the star is back again. I hope this makes it clearer now. So let's run this, and here we have our 15. And so these are the most important things about pointers. What does the ampersand do? What does the little star do? How you can create a pointer, how you initialize it, and how to work with values. Now let's do some practice with all this. So let's remove all this and let's create a new pointer and initialize it. And here let me comment everything. So create a pointer and initialize it. And let's also print it. Now if we want to insert something in that memory slot, we use the star and we put the value we want. In here we are saying, in that memory slot, store the value 5. Now if we print star z, it means print what is stored in that memory slot. Now this is the address and value of the address. Good. Let's create a pointer this way and leave it empty. Now let's just have a variable w as an int. Now if we print x, means print the pointer, the memory slot x, which is empty. And let's also print the address of w. Print the memory slot that holds the value of w. Now let's give x, which is a pointer, an address value, and print it again. Now you see the first one is nil because x is empty. The second one is the address of w. Even though we did not assign any specific value, by default it should be 0. Because if you declare a variable and do not initialize it, like we've seen with the pointers, by default in Go, it is going to assign like the 0 of that specific type. But also things can go wrong sometimes, so we still have a valid address because the memory slot was assigned to it, but it's also better and safer to initialize all your variables. And finally, yeah, x is pointing to that same address. Now let's do something interesting. So this is w, which is still empty. And let us do this. And print the value of x and also of w. So what do you think it's going to print in here? Yes, both of them are 3. So you may think this is strange, like we did not assign 3 to w, but this is the power of pointers. This is the main point of pointers, because you can reference that address since you have it by any variable. So in here I was able to control the value of w by using another pointer. Surprisingly enough, or maybe you have seen before, the double star int, and it is actually the address of the address. Let's look at this. We know x is a pointer, so an address, and let's just try to print its address. We can use this type of function to see what are the types of each variable. And here, the address of x is of type double star int. I hope it makes sense to you right now, since you understand the concept. It is not so scary anymore, right? And so we said that pointers allow us to control memory, like we've seen how we put the value 3 in W, which is very important, and let's see how we can make a better use of this. So say I created this function double, again simple, it's just going to double the value of an int and print the result after being invoked in main. Well, we see here that the value is only doubled inside the function, not in main. A solution to this, as you may have thought of, is to return the value. But this is considered as a waste of instruction in terms of like CPU efficiency and so on. Now let's try something else. Let's pass our pointer instead. And let's get that exact address and double whatever it is in there. And here we see the value is doubled instantly. And this is not only good in terms of instructions, but also it gives you control about values that you want to change and the values that you really don't want to change, but you may need to use in your computation, and you want to make sure that at the end this value will stay the same. And this could be very important in a real business case scenario. And let's see how. If you have followed my previous video, we always use the struct to create users. Now let's talk a bit about structs before. Well, they are custom data types that you create doing so, type, the name you want to choose, and struct. Here we are using the name user. We will keep our structure simple. We just have name and age. The same as pointers, I will use new to create my user. And if I print the type of that, you will see it's star user, so it's a pointer to a user. Now when we fill it with some data and print it, the ampersand there tells us that it's a pointer. Doing so will give us the same result by using a new. We are given an address as we have seen before and not nil. And by removing the ampersand, it's no longer a pointer. So let's play around with this like we did with the integers. So we've seen, by giving the pointer, changes are made effectively. So this is a short structure, and if we did not use a pointer, we'd be copying all these fields. Now, if you have seen my previous videos, this is how big some structures can be. Imagine you have to copy all these in order to just make one change. Like, you see how ineffective that is? And with pointers, we're going to that address, we're not copying anything, and we're making our change in a very efficient way. But you know, there is even a better way to deal with structs. As compared to other programming languages, Go has made something called methods. When we put user, it allows us to modify the struct in place, since it's a pointer receiver, and we don't need to pass the address of the user explicitly, and this will work with any instance of that structure. Isn't this just easier to read? So thank you very much for following along. I hope this video has made these concepts clearer, which are important concepts that will come in handy in any future applications you want to create.